So the next task that we want to be able to complete is to actually multiply two matrices by each other. So we've added matrices together, we've subtracted them, we've multiplied a single matrix by a scalar number, and now let's multiply two matrices together. So when you're doing a matrix product, the resulting matrix will be of the format when you take basically a row multiplied by a column, so A is a row matrix and B is a column matrix. What you end up doing is multiplying the corresponding entries and then adding them together. So this row matrix A times column matrix B would end up actually being a single value where I take A1 and B1 and multiply those two together. And then I add that to A2 times B2, and so on and so forth until I run out of elements. And then I add them all together, and that is my answer. I'm going to introduce this idea to you as an application, and then we will move on from there. So why might we want to do this? Okay, so we have Sporting Chance, a retail sporting goods store. It said that its downtown store had 20 metal, 12 graphite, and 48 wood tennis rackets. We're going to make this a row matrix R. So we have 20 metal, 12 graphite, and 48 wood tennis rackets. And I put those in a single row with entries 20, and I'm going to label them M for metal, G for graphite, and W for wood, just to keep track of context. Okay, and now we have some additional information. We now know some costs. So it says the metal rackets retail for $60, graphite for $110, and wood for $40. Put these prices in a column matrix C. So I'm going to draw a single column. I'm going to put these entries in, so first 60, then 110, and then 40. And again, so that I can keep track, I'm going to label those M next to the 60, G next to the 110, and W next to the 40. Now we want to find R times C. So we want to multiply the row matrix that we made in part A with the column matrix that we made in part C. It says note the dimensions of each matrix as well as the dimension of the result. Okay, so what I'm going to notice here is R is a row matrix, one row by 3 columns, and C is a column matrix, which is 3 rows by 1 column. And I don't know the dimension of the result yet. We'll write that down when we get there. Okay, so what we want to do here is we want to basically multiply the corresponding entries, and I'm going to color code it. So first entry in R is 20, and the first entry in C is 60. So we're going to do 20 times 60 plus, okay, next entries. Next entry in R is 12, next entry in C is 110. So 12 times 110 plus, I'm going to change the color of my pen one last time. Last entry in R is 48. Last entry in C is 40. So 48 times 40. Okay, now I'm going to actually go through and multiply these out and add them together. So you might want to grab out a calculator to do that. Take 20 times 60 plus 12 times 110 plus 48 times 40, and you should get 4,440. This is a single entry, but it is technically still a matrix. It just so happens to be a 1 by 1 matrix. A single entry is 1 row and 1 column. What's the practical meaning of R times C? So what did we just find? When we multiplied all of the amounts of tennis rackets by their respective retail prices and added that all up, we just found the total retail value of all of those tennis rackets. So that's the practical meaning. That's $4,440. Okay, so this Sporting Chance, it actually has 3 stores total. Besides the downtown store, which we just looked at, there's also a suburban store and a store in the mall. So now we have the numbers of metal, graphite, and wood rackets in each store listed in the following matrix. So now we have a 3x3 matrix. The first row is the same as R. That's the downtown store, which had 20 metal, 12 graphite, and 48 wood. But now we have a second row, the suburban location, that has 16 metal, 9 graphite, and 30 wood. And the store in the mall has 25 metal, 18 graphite, and 36 wood. So we have 3 rows now in our matrix, and along with the 3 columns that we already had. So if we want to compute the retail value of the rackets for each store, we basically have to do 3 calculations like the one in number 1, the one that we already did. And we can organize them as follows. So what's happened then is we already know the first entry. We've already taken 20 times 60 plus 12 times 110 plus 48 times 40 and found that first entry is 4,440. We already knew this one. But now we need to do this process again for the other values. So let's see, we need to take, I'm going to write it out to the side, we need to take now 16 times 60, so across the second row, but down that same column. Add that to 9 times 110, add that to 30 times 40. So I'm going across the second row and again down this column. And when we compute that, and I'm adding that on my calculator right now, we get 3,150. And then we need to perform one more calculation where we're going to now go across the third row and again down the column. So this one will be 25 times 60 plus 18 times 110 plus 36 times 40. And again, grabbing out a calculator to do that really quick, we should get 4,920. So what I did was I introduced those horizontal lines in the matrix on the left to indicate how the rows are used one at a time, like a row matrix. So each row on the left contributes to one entry in this 3x1 answer. Our answer indicates that the rackets have a retail value of 4,440 at the downtown store. Again, we knew that from the earlier answer. And then of 3,150 at the suburban store and 4,920 at the mall store. Again, it says to note the dimensions of each matrix and the dimension of the result. So this time we had a 3 by 3 matrix, and this one is a 3 by 1 matrix. And notice that our answer is also a 3 by 1. And we're going to be creating, hopefully establishing a pattern for how these matrix multiplications work. So for right now, just think about how those numbers sort of line up and relate to each other. Finally, it says for insurance purposes, Sporting Chance needs to know not only the real retail value, but also the total wholesale value of their tennis rackets at each store. The wholesale prices are $35, $60, and $25 respectively, so for their metal, graphite, and wood. So what they've done now is they've put that as a new column matrix. So the first column now are all of the retail prices that we've been using. And the second column are all these new wholesale prices. So our second matrix now is a 3 by 2. The original matrix over here is still a 3 by 3. So now we want to calculate both the retail and wholesale values of the rackets. So again, we already know some of these entries. We've already calculated all of the retail values by going across and down, across and down, across and down with the first column. So I'm grabbing all these numbers from what we just did. The retail values were 4,440, 3,150, 4,920, and those were retail values. But now we're going to do this process again for the wholesale prices. So I'm still going to be going across my first matrix, but this time down the second row, or sorry, down the second column. Okay, so to find this first entry over here, we're going to do 20 times 35 this time, plus 12 times 60, plus 48 times 25. And if you multiply that all out, add it together, you should get 2,620. Okay, move down to the second row. We're going to across that second row and again down the second column. So 16 times 35 plus 9 times 60 plus 30 times 25. And that totals 1,850. And finally, across the last row and again down that same column, 25 times 35 plus 18 times 60 plus 36 times 25 gives us 2,855. We already have the dimensions of each matrix. The dimensions of the result is a 3 by 2. Join me in the next video to hop back in on what these dimensions have to do with anything.